In this video, we solve the numerical of continuity equation. So first we understand the problem statement. The diameter of pipe at section 1 and 2 are 10 centimeters and 15 centimeters respectively. Means here one pipe is given and the diameter of the pipe is gradually increasing toward the outwards. So here we see this diagram of this pipe. So here the diameter of the pipe is the 10 centimeter and here the diameter of the pipe at section 2 is the 15 centimeters, and we need to find the discharge through the pipe. Discharge through the pipe means here we need to find out the Q. If the velocity of the water flowing through the pipe at section 1 is 5 meter per second, means here the V1 is given. So velocity at the section 1 is given, it is 5 meter per second, and we need to determine the velocity at section 2, means we need to find out the V2, means velocity at section 2 we need to find out. So first we mention this given data here. So first diameter D1 is given, that is the 10 centimeters. We also mention in this image the D1 is equal to 10 centimeters and 10 centimeter is converted into the meter, means 10 divided by 100, then we get the answer in the meter, it is 0.1 meter squares. From the diameters we find out this area. So it is a pipe, means it have a circular cross section, and the area of the circle is find out by using this equation. This is pi by 4 into d1 square, and here we put this d in a meters, so that is a 0.1 meter. So we get the area, it is the 0.007854 meter square. Next parameter is given velocity at section 1, that is V1 is given, it is the 5 meter per second. So V1 is equal to 5 meter per seconds. And then second parameter is given from the section 2. So at the section 2 diameter is given, that is a 15 centimeters. So 15 divided by 100, so we get the answer in meter, that is a 0.15 meter. So in this diagram also we mentioned that D2 is equal to 15 centimeters. And from this diameter we find out this area by using this equation, that is pi by 4 into d square. So here we get this area at the section 2, and we need to determine the Q. So here we mention that first we need to find out the discharge Q, and second we need to find out velocity at section 2. Velocity at section 2 means the V2. Okay, so here we mention we need to find out the V2. So here we solving this numerical of continuity equation. So what is continuity equation? Continuity equation is equal to rho 1 into A1 into V1 is equal to rho 2 into A2 into V2. Okay, but here the water is given, means density of the water is same at the section 1 as well as section 2. So continuity equation is the A1 V1 is equal to A2 V2. So here A1 V1 is given, A2 is given, so we are able to find out the V2 by using the continuity equations. Now how to find out the Q? So Q is equal to area into velocity. So at the inlet area is given as well as the velocity is given. So we multiply these two things and we are able to find out the Q. So first we find out the discharge Q. Q is equal to A1 into V1. So area we already find out, it is 0.007854, and the velocity is given, that is the 5 meter per seconds. So we multiply these two value and we get the answer of the Q discharge, and the unit of discharge is meter cube per second. So how this unit is comes? So here we see this unit of area is meter and the velocity unit is meter per second. So meter square into meter, it is converted into the meter cube and divided by seconds. Now by using continuity equations we need to find out this V2. Okay, so here we can check the A1 is given, V1 is given, and the A2 is also given. So what is the equation of the V2? Equation of the V2 is equal to A1 V1 divided by A2. So this A2 is supplied here on the left side. So we get these equations, and we putting this value of A1, it is 0.007854 into V1, it is 5, divided by A2. A2 is 0.01767, and we multiply this value in the calculator, then we get this value of V2, that is a 2.22 meter per second. So here we can see that the velocity is reduced. So here we simply applied our logical mind that when the area is increased, so here we see this area of the pipe is increased. So when the area is increased, the velocity is reduced. So from that we can understand is our answer V2 is always less than the V1 because here the area is increasing. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more video related to FMHM as well as other subject of mechanical engineering. For FMHM, various link is given in descriptions as well as in car. For other subject, I request to visit the playlist.